Okay, so today what I'd like to do is talk about something that happens in the context of some of the other things we've looked at. If you recall the Cynefin framework, which I think was maybe episode 2, the distinction between the complex and the complicated. And in the complicated, what we noticed was that making effective choices was relatively straightforward, which is to say that in the complicated, the relationship between cause and effect is relatively easy to figure out and doesn't change in any meaningful fashion. And so we can build expertise, and then we can set goals and we can develop strategies to be able to achieve those goals. And that toolkit is effectively the complicated toolkit. And in the context, though, of complexity, this entire toolkit doesn't work. Cause and effect are not obviously easily related. Things are changing too rapidly. You can't actually have goals and strategies in complexity. What you do have is you have principles. And so what I'd like to do today is talk about a particular principle, to take that as the object of inquiry. And the principle I want to focus on is, I think, quite useful in the contemporary environment, and that is the principle of closing loops. Okay, so to walk through that principle, what I want to start with is the body, the human body as our example. And what we can say is that the human body can be perceived as a mesh of a wide variety of distinct cells and organelles and organs and metabolic processes and other biological processes that hang together in a homeostatic equilibrium, which is to say that this complex mess of billions and billions of different cells is somehow able to work together to achieve the ability to actually maintain conditions in its environment that are conducive to the long-term well-being of the system itself. And a big part of that is the way that this system connects together in closed loops. And so what I mean is, for example, let's take a given process, like say the contraction of a muscle fiber. That process requires certain inputs. So it plugs into the environment and looks to the environment to provide the inputs that it needs to be able to achieve its particular function. It then provides that function, whatever it happens to be, and as one of the consequences of that, it produces outputs. And now here's the key. Those outputs are the waste products of the process, and it is necessary to achieve homeostatic equilibrium that there be some other process that plugs into those outputs and has the capacity to convert that waste, to convert those outputs into useful inputs to provide other useful functions. So this is a closed loop. And the point is that the human body, as an evolved biologic system, is actually extraordinarily effective at closing loops. If you imagine, for example, the notion that you can eat just an apple and that will provide enough nutrition in the form of calories and energy and other kinds of nutrients to power this whole giant body for hours, even running around and lifting things and thinking about stuff. This is an extraordinary amount of efficiency and then a relatively minor amount of ultimate waste product. To achieve this level of efficiency and maintain homeostatic equilibrium, these loop closures require a couple of different characteristics. One, of course, is the fact that you actually have to close the loop in the sense that for every output, there needs to be some other process that receives it as an input. But then two, there actually needs to be a symmetry between the capacity of output and the capacity of input. Right? So if my muscles are producing lactic acid at a rate that is much faster than my body's ability to process that lactic acid, then what happens is that I will run into what you might think of as pure waste. And this pure waste will show up as toxic in the body. So then I need to have some kind of mechanism whereby either the rate of production or the rate of processing is brought back into symmetry. Right? So maybe something happens where my muscles just can't fire any longer. There's just too much lactic acid in the environment, so I can't produce any more lactic acid, and then the body can ultimately get itself back into equilibrium. And if I can't do that, if the rate of production continues to outstrip the rate of processing, then I end up with a toxic environment. And of course, at certain levels, this will begin to break down the well-functioning of the broader system, and then of course eventually would lead to death. And so that's that, right? We have a homeostatic equilibrium driven by a mesh of different systems and processes that are able to, at a very high level of effectiveness, close all loops. Now, of course, there's a limit to this effectiveness, that there is always going to be some portion of output that can't actually be turned back into input. And so this, of course, is pure waste. And the body has to have a mechanism for grabbing that pure waste, isolating it, pulling it out of the environment where it's currently toxic, putting it into other environments like the colon and the bladder, and then exiting it from the body altogether. And that's that. And that's it. Like, that's how one of the primary mechanisms whereby we're able to maintain equilibrium. But now things, of course, get more interesting, because I can say that I'm exiting pure waste from my body into the outside, but properly, of course, what I'm really doing is I'm exiting things from one inside into a nested, larger inside, because, of course, my body is part of a larger ecosystem, it's part of the environment. So when the bear shits in the woods, the output from the bear becomes input to dung beetles and fungi and other microbes that are then taking that as inputs, that are processing it into outputs that are useful in the broader context of the ecosystem. And we know actually that the effectiveness of these loop closures in long-standing ecosystems are also remarkably effective. And in some sense, this is kind of the point of biology, of life, is that life exists on the basis of its capacity to maximally effectively process energy that comes into the system, resources that come into the system, with the absolute minimum amount of waste, and then outputs that waste as delicately and efficiently as possible to maintain the minimum amount of toxicity. And over the past couple billion years, the biological environment has gotten pretty good at that. Now, of course, there are limits. We are always bounded by thermodynamics, and so our pale blue dot is by necessity connected as an open system to the sun, which provides us with most of our free energy, and to the legacy energy embodied in various material resources on the earth. But within those contexts, the biological environment does a remarkably effective job at closing loops. So then we bring human beings back into the story, because one of the things that we have been able to accomplish is the ability to extract and concentrate resources at a level that is just orders and orders of magnitude more intense than nature has ever perceived and had to deal with in the past. So as a consequence, the rate of production of output of human industrial social processes is just way asymmetric to the natural environment's capacity to take these as inputs and convert them back into closed loops. So as a consequence, of course, we're producing waste all over the place. We're producing waste nitrogen and waste phosphorus. We're producing waste carbon dioxide. We're producing waste uranium. We're producing waste estrogen. I mean, just the output of our human environment is open loops all over the place, and as a consequence, waste all over the place. And as a consequence of the sort of increasing rate of output with no real significant increase in the rate of input, toxicity everywhere. And so, obviously, just as in the case of the human body, the consequence of this toxicity is a breakdown of the well-functioning of the processing system, the homeostatic system, and then ultimately death, which may occur within the lifetime of the people watching this video. So it's sort of worth contemplating. But now things actually get even more interesting, because when we're dealing with humans, we've so far been talking about this question and this problem of closed loops in the context of the physical, of molecules and physical nature. But we can and should also talk about it in the context of the social. Our social environment, our civic society, is itself something of an ecosystem. We have relationships, we have communication channels, we have dispositions, and these are affected by the flows across those channels. And when they're working well, they also operate as some kind of homeostatic system that is able to maintain the well-being of the whole over some enduring period of time. So take, for example, something like advertising. And in this context, we can think of advertising as something which has a very, very open loop within the ecosystem of civic society. That the outputs of advertising are the sorts of things that so quite significantly outstrip the capacity of our collective sense-making mechanism's ability to process them into useful goods, that it produces just an enormous amount of toxicity. Advertising breaks down the efficiency of our communications channels, and it breaks down the quality of our relationships. It generates a lack of trust. It generates ambient distrust, and it creates just an enormous amount of noise, in much the same way as, say, lactic acid in a muscle system. And our collective intelligence does not yet have any meaningful capability to process this noise and these breakdowns of relationships at a level vaguely symmetric to the accelerating capacity to produce it. Now, of course, for some period of time, we were able to more or less get along, but in the context of exponential technology, social media, infotech, etc., psychology, neuroscience, the rate of the output of this waste into the social environment now so vastly outstrips the capacity of the environment to endure it, much less to process it, that we're beginning to see a breakdown of civil society. So on the one hand, we need to close those loops. We need to find some way of building in those symmetries of output and input, and we need to build in mechanisms that rate control output and input so as to maintain it within some sort of equilibrium. Or so as to avoid some level of catastrophic collapse, death at the level of civil society. But if we close the loop and go back to the first point at the physical level, the problem is actually even more significant. Because not only do we need to avoid a meaningful degradation of our collective intelligence, we actually need to witness a quite substantial increase in capacity. Because obviously, if we want to go about being able to have the level of perception and the level of understanding and the level of skillfulness in collective action to be able to be equal to the amount of output that we generate into our natural environment, if we want to be able to monitor the presence of nitrogen in every cubic centimeter of the ocean and then be able to understand how that nitrogen fits into various kinds of processes, both negative and positive, and then be able to generate mechanisms whereby we can either process it or reduce the input so that it actually maintains homeostatic equilibrium with the entire global ecosystem, well, that's a lot more than we can do right now. So we actually need to quite substantially upgrade our collective capacity to engage in these kinds of activities if we want to have any chance of being able to be equal to the problem of closing loops at the physical level. And I think that needs to be taken seriously. My sense is that there's a strong intuitive sense that there is a need to close loops at the physical level. And I think there's also a strong intuitive sense of the need to close loops at the social level, and frankly now even at the personal and relational level. But it's a far cry from sensing that something is necessary to being able to actually take responsibility for it, to being able to really quite deliberately operate in a truly agentic capacity in relationship to a problem of this magnitude. It means being able to actually go slowly and understand how much you can actually do, and then understand how you can go about building the capacity, building the individual and collective sovereignty that is adequate to the level of complexity of the problem domain under investigation. Of course, that's a lot, and will have to be the subject of another conversation. I hope this was helpful.